How are you, and welcome back to my channel. Today we are learning about three-dimensional geometry, and specifically we are narrowing down to three-dimensional geometry in a pyramid. As you can see, we have a pyramid A, B, C, D, and V, which is a rectangular based with a height VO, as you can see it. Our first question today is find the angle between line AV and plane ABCD. That is a concept on angle between a line and a plane. Now, to find an angle between a line and a plane, you find the angle between that line and the projection it makes on the plane. So the projection of AV on plane ABCD is AO. When you move from A to V, then downwards to O, then back to A, so the projection of AV is AO. Therefore, I've drawn it here. So we have AV, which is 13 centimeters, and we have AO and OV. AO is the projection. So to find AO is a half of AC, and a half of AC is that is 8 squared plus 6 squared under square root. That is the hypotenuse, which is 10 centimeters. And AO is a half of AC, therefore AO is 5 centimeters. And VO, which is the height, now we take now 13 squared minus 5 squared, which is under the square root, which is 12 centimeters. So to find the angle between AV and AO, we also have VO, so we can use tan, which is tan theta is opposite, which is 12 over 5, which gives us 67.38 degrees. So somebody else can use cos. If you use cos, cos theta will be adjacent, which is 5 over hypotenuse, which is 13. Somebody else can use sin theta, which is opposite, 12 over hypotenuse, which is 13. So you are not restricted there. Question B is find the angle between line VAB, not line but plane VAB and plane ABCD. That is the angle between two planes. VAB is a plane. If you go back to the diagram, VAB is a plane and ABCD is also a plane. Now, to find angle between two planes, you bisect each plane. So if I bisect plane VAB at the middle there, if I bisect plane VAB at the middle, then I also bisect the bottom plane. Now I'll meet the height, and the line of intersection, which is common between the two planes, is AB. So automatically the angle will be on AB. So as I've said, to find the angle between two planes, you bisect each plane. So I bisect VAB, and I also, from the same point, I bisect plane ABCD. But when I meet the height, I can stop there. So the angle is between the two bisectors, the bisector of VAB and the bisector of ABCD. So the angle is in between. As you can see, from this point, I can even call it X. So point X to O is a half of the 6 centimeters. That's why I've written here 3 centimeters. And the height, remember the height of the pyramid was 12. So those two measurements are enough to give me the angle between plane VAB and ABCD. So I can automatically use tan. Tan theta is opposite, which is 12 over adjacent, which is 3. That one is giving me 75.96 degrees. Our last question today on 3D on a pyramid is angle between BVC and ADV. Now BVC again is a plane, this plane, and ADV is the back plane. So again, angle between two planes, I bisect two planes, and the angle is found at the line of intersection. So you can see the common point between BVC and ADV is V. V is common. So therefore angle will be found there at V. But before that, as I've said, angle between two planes, you bisect each plane. So if I bisect VBC at the middle, as you can see, and I also bisect the back plane, which is a ADV, and I create a triangle there using that red pen. So the angle is at the top at point V. So when I pick out the triangle, it will be like that. Remember, this measurement is 8 centimeters. So I've subdivided 8 into 4. And remember, you still have our height at the middle there. So that's why we are having this height here as 12. Now I have 4, and I want to get the angle at V. So I can create 2 triangles there, and use one triangle to get one angle, then times 2. So tan theta, if theta is here, is opposite over adjacent, which is 12. That's why I've written a tan inverse of 4/12, then times 2. I'm getting the angle as 36.86 degrees. And that is in for today. Thank you for watching.